Okay, so thank you everybody to be here. Today I will be talking about Search API, the Search API modules that probably all of you have used, but using a different kind of service to index and manage results. It is called Typesense. We talk about this integration. Just a couple of words about me. I'm Luca from Italy. I work for a company called SparFabric in Milan. I'm a Drupal contributor since a long time. I maintain a couple of modules like Web Profiler, Monologue, and something else. And the one we are talking about today, that is Search API Typesense. You can find me using my surname and name everywhere, basically. Just a couple of words about SparFabric, because I'm here thanks of them. SparFabric is a company of engineers, developers, and designers. We develop custom applications, basically in cloud-native environment. And since last year, we are working a lot in the artificial intelligence fields. So we are trying to understand how and what we can do with artificial intelligence. We are partners of the main cloud vendors, like Google Cloud Platform, AWS, or Alibaba Cloud. And we are member of some open source foundation in Europe, basically, and not only in Europe. We are silver member of the Cloud Native Computing Foundation, the Open Source Security Foundation, and the Linux Foundation Europe. So we are an open source company, basically. Oh, wow, this is okay. Okay. Just okay, it was. Okay, so Typesense is a search engine that is open source. It's very fast, it's very developer friendly. You can install it very easily. And it uses a lot of modern technologies, and it runs on every hardware, and it embeds a lot of features for AI functionalities. We will look about that later. Basically, they market itself as an open source alternative to Algolia, that is a big search engine, but is closed source, is commercial. And Pinecone, that is a vector database, also closed source. It's very easy to install and to use compared with Elasticsearch or Solr, for example. We see how to set up Typesense and use it. It is very, very easy. It's written in C++. It's very active on GitHub. And you can install it on your infrastructure because it's open source, so you can self-host it. Or the Typesense, the company that build the software, offer a software as a service environment. It's called Typesense Cloud, and you can use it if you don't want to set up an infrastructure yourself. They maintain a public roadmap, so you can see the advance of the development. You can suggest new features. You can open requests for bugs or whatever. The current version right now is the version 28. It has been released a couple of weeks ago, and every 2 or 3 months they release a new version with a lot of new features. They are working on the version 29 right now. They have a public Slack workspace where you can ask for support, ask questions. They are the community behind Typesense is very active, so you can ask for help, and you will receive an answer very quick time. Typesense itself doesn't have a UI, so it's just a REST server. You can talk with the server using REST endpoints. If you need a UI to configure it, you can use the cloud version, so Typesense Cloud, that is a paid product, or you can use this Typesense dashboard, that is a Docker image with also a standalone application that you can install on your computer or in your infrastructure, and you can use it to manage Typesense. The Typesense itself has a lot of features. Some of them are typical for a search engine, like typo tolerance, or the tunable ranking, so you can rank how the sorting of the results. But there are also a lot of interesting features. For example, the merchandising one, we will talk about it later, where you can promote a specific result on your result page based on conditions. You can sub synonyms. You can do, of course, filtering, faceting. You have geo search support, and we'll talk about that. Of course, Typesense itself is a vector database, so you can index also vectors and can use it to perform semantic search using an LLM, and then converse with the content you index. We will see an example later. There are API libraries officially supported in many languages, so the Typesense community provides a client to talk with the Typesense server in many languages. PHP is one of them, but if you have a mobile application, for example, you can route the client to talk with the Typesense server directly in JavaScript, for example, or Swift, whatever you want. There are also integration with the existing platforms. So, for example, there is an integration with Magento e-commerce system, with WordPress, and so on. Since last year, exists also an extension for an integration for Drupal, and that is the main topic of this presentation. So if you did that link points to the Drupal.org project page of the Typesense API, Search API Typesense module. So it's not officially supported by the Typesense team, but it is listed on its API client page. Okay, as we said, there's a module for that. So the Search API Typesense, you can install it using Composer like any other Drupal module. It downloads also the Typesense PHP client to interact with the server. And then you can try it on the dev, for example. There is a dev add-on available, so you can install it on your dev environment, and it provides both the server and the dashboard that we talked before, just with a single command. Okay, so now we try to do a demo. So I try to show you how all this integration works. To do that, I prepared a standard Drupal 11 website with 49 nodes. I just took contents from this website, this Drupal at your fingertips. That is a website with a lot of knowledge about Drupal, very useful. I just that is provided in Markdown format on GitHub. So you can, if you go to the website, it's a static website. There is a link. You can download all the contents in Markdown. I just wrote a migration to insert those contents as Drupal notes. And then we can use these contents to perform search. I do one thing more. For every content that I downloaded from this website, I just ask an LLM to generate a summary of contents to populate the search result page, because just because those pages doesn't have, maybe some of them doesn't have a summary, a text that can be used to render the search page. So all those notes as a body, a category that is taxonomy, simple taxonomy with a couple of terms, and summary that is generated by OpenAI, in this case using the AI module, of course. So, first thing, as in every search API setup, you have to create a server. And in this example, is big enough, you can read, okay. In this example, I set up a server using a local Typesense instance and a search API server that talk with an instance on Typesense Cloud, just to show the differences. And when you create a connection between Drupal and Typesense, you just have to insert an admin API key that you set up when you start the server. So when you start the server, you have to insert an API admin key that gives you all the rights on the Typesense server. Then the host name where the server is, a port, and a protocol. When you run a Typesense on dev, you only have one node. If you use Typesense Cloud, they provide you, if you want, an high availability infrastructure when you have multiple nodes, so you can add more nodes here to connect all of them to have high availability. And then after you do this connection, for example, you can start using information provided by Typesense itself. For example, Typesense provides a metrics endpoint that gives you some internal metrics of the server. For example, all the CPU's usage, all the memory that the server requires, the space on the disk, and so on. The memory active is one of the most important information here, because as we see in a minute, Typesense is quite fast. So even if you search on a huge dataset, results comes out in milliseconds. To achieve this performance, all the index is in memory. So you need a lot of memory, a lot of RAM to store the index, and this matrix represents the amount of memory that my index in this moment requires. That is not only the 49 nodes. See in a minute. I have 2 indexes on this server that requires these 180 megabytes of RAM. Then you can configure API keys. This is because usually the standard configuration is that your client, so the front-end interface that performs the search and show the results, usually runs directly on the client side, on a mobile application or on JavaScript on your Drupal website. So you need an API key that have only the permission, in this case, for example, to search on a specific collection. In Typesense, a collection is the same as index in Search API world. So it's a synonym of an index. In this case, I create an API key that can search documents on this keyword underscore search collection. I can use this API key on a front-end application, and if someone try to perform other action on the Typesense server, of course, he cannot do anything. Okay, then you can configure stopwords, for example, because maybe you don't need to index or search for stopwords, so you can create a stopword set, and then you can use it when search on your server, and it skips all the words in these stopwords. You can create more than one. I can use it when you search, when you perform search. Okay. So this is the configuration of the server. Then we have to create an index. So, for example, I create this keyword search index where I index content, so basically nodes, only of kind basic page in all languages. We have only English nodes here. So it's the same. And then I select Typesense local, that is the one that runs on my machine, to perform the indexing and the search. Okay. Then, as any Search API setup, I have to choose which fields I want to send to the search engine to be indexed. In this example, I sent the rendered item, so the rendered HTML of the node itself, then the category field, that is the taxonomy field, the node ID, the summary field, that is one generated by OpenAI, and the title of the node. There is one thing to see here, that is the type of these fields for Search API is specific to Typesense. So there are a set of types that are defined by the module that must be used when those fields has to be sent to Typesense. And you have different kind of fields to index something like a string or a integer or a float or a boolean, and an array of those. So you have, for example, the rendered HTML output is a string, but the category, that is a taxonomy reference, is an array of strings, because I can have multiple terms for each node. For example, the node ID is an integer, the summary and title are strings. Just saving, this is a big difference between the standard usage of Search API and this integration. Just saving this change is not enough to complete the configuration of the collection on Typesense. You click Save Change here, and then go maybe on View and click on Index Now. It doesn't work, because Typesense needs some more information to be able to build the collection on its side. You have to provide what they call a schema. You can also do a schemaless setup but it's not so efficient because Typesense try to guess the kind, the type of each field based on the first document you send to it. And maybe it's not, can do something wrong. So usually, you have to provide a schema. And in this schema, you can set, for example, the field that can be used for sorting, that must be a number in Typesense. So you can only choose the node ID in this example because it's the only field that is an integer. And for every other field, you can configure, for example, if that field is a facet, it has to be used as a facet. If it's optional, you cannot send a document to Typesense with some field that is not marked as optional without information. So, for example, if you, on your Drupal side, you have a field that is not required, and you create a node and that without information in that field and try to index node on Typesense, you receive an error because every field are required if this optional is not checked. Then you can choose if this field has to be indexed. This effect on the searchability of this information, because you can send to Typesense all the information from your node, but some of them maybe cannot be used for search information, and this is useful typically when you have a client application. So you have some information that is required to be rendered in the client, maybe a link to something, but you don't want to search that string. Okay, and this is useful because the amount of RAM used by the index is only for the information that can be searched. So if you have a text that can be returned to the client but not searched on, you can turn off this flag and you use less memory. The same with store, but it's the opposite. The store fields ask Typesense to store the field on this persistent storage and return it to you when Typesense gives you the document back. Then you can choose if these fields can be sortable. So if you can sort the results based on this field, the locale of the field that is used for tokenization. Usually, every Latin language should be set as English. If you index something like Japanese or other non-Latin chart set, you can set a different locale. Then you can enable the stemming. So you want to stem your term when they are indexed in the search engine. The new version of Typesense, the 28, also allows you to upload your custom stemmer if you are using a language that is not supported by the Snowball stemmer, that is the standard implementation of a stemmer. The module does not support this new configuration at the moment. And after you have configured all those information for all fields you have, you can save this form, and this operation will create the collection on Typesense. So from now we can start sending documents and start searching for results. If I click save here, okay, in this case I don't change anything. If I change something, for example, let's say that also the summary fields is optional. Okay, what it happens is that the schema is updated, and the module automatically removes all the contents from the server because the scheme is changed, so probably to re-index all my contents. So, for example, right now there are 0 content indexed. I can index them on Typesense, and now I can search for them. To check if the index works, we provide a page on the backend of the module itself, on the Search API interface, that provides a search interface just to test if the data you sent to Typesense is correct, for example. So in this case, I indexed 49 contents. With those 3 taxonomy terms that are marked as faced, so you can filter on those faced, and then all the text that I sent to Typesense that contains the category, the node ID, rendered item field, rendered item content, the summary field, the title field. The ID is something internal to Search API, and Typesense is the entity, the name of the entity, and the ID of the entity, and the language. And then I can use this interface to perform a search. So this is more or less the experience your customer will have using a front end built for Typesense. For example, okay, now I have only 49 nodes, but the results come back in 17 milliseconds. So it's quite fast. So the server is local on my machine. Later we can try with the Typesense Cloud, but the time is not so different. Also, performing some filtering is quite fast. So, for example, I want the node that contains CK-edit term, and that is tagged with the front-end taxonomy term, and I receive the results in 21 milliseconds. So it's quite fast. This interface is just an example about how to build a search result page. I have created one here just to show you how to do that. It's not pretty because I'm not a front-end developer, so sorry, but just to show you how easy it is to implement a search result page that uses Typesense as a backend search engine. So, for example, here, if I look for the same CK editor, for example, this is the results that I receive back. This interface and the one provided by the module is built using a JavaScript framework, a JavaScript library, that is called instancesearch.js, that is provided by Algolia. It is one of the main one of the company that provides a service similar to Typesense, but they developed this library and is open source. So the front end that use Algolia is open source. So the developers Typesense provides an adapter that converts the call to be correct for Typesense, so you can use instance search. And for example, in this page, you can see all the widgets that instance search provides you. So the statistics, the search box. You can provide the results or an infinite results with a pager, basically, or an infinite scroll of results, facet, numeric or with range or slide. All those widgets are implemented. You can just add your CSS to style them. And just to show you how easy it is to implement these, that the page on Drupal website, so this one, is built using a standard Drupal controller that renders a template. The templates use this JavaScript. So if you open the templates, it's just a standard twig template that attach a library. This library creates a Typesense instance search adapter. Here you have to insert the API key. That is one we create before. This API key only allows to perform search on a specific index. You can, in this example, I hard-code here the connection information. You can, of course, pass all those information in a Drupal settings or whatever you want. And then you set the parameters that must be used to perform a search. So, for example, I want to search in two fields, the title and the rendered item, for example. About anything we talk later. And then we create an instance search object that using the search client that is built from the adapter that runs on this keyword search collection or index. Routing is very useful and it basically adds on the query string of the page the things you configure in the interface, so you can copy and send this URL to someone else, and it performs exactly the same query. So, for example, if I click on site building, this has been added automatically to the query string. This is done with this routing. This search function is to mimic the standard behavior of Drupal when you start with a empty page with just a search box. Because usually those kind of search engine do something differently. So when you open the page, you have all the results. And then when you start when you start typing a query, it reduces the number of the results. So this is what you call search as you type. Then no, not this one. Okay, and then you can add widgets. So for example, there's a widget in the instance search library that it's called configure. For example, to set how many index per page each page you want. There is a widget that it's called search box. That is the text field where you insert your search query. There is a widget for the hits. Every widget has a templates field where you can configure the markup of every widget itself. So, for example, the item returned by the search use this markup, for example, and so on. A refinement list for facet, the pagination, and the statistics. All of them are attached to a specific ID element in the templates that is exactly the same you wrote in the templates. Italo? Exactly. Okay. Okay, so the question is, usually on Search API, we build a view, build on the search index, and then configure the view. You can do that. The module does not provide an interface with view, because the big advantage of Typesense, of system like that, Typesense or Algolia, is to be as fast as possible, as agnostic about the framework itself. So you can use the same JavaScript on a Drupal web page, on a mobile application, or whatever. And in a typical Search API with views configuration, you have a twig page that calls to views, that calls to Solar, so you spend a lot of time just because you have Drupal in the middle, basically. With this configuration, the contents are indexed in Typesense using Search API standard in Drupal, but the search page is built directly on the client side. Of course. No, you talk direct to Typesense. So Typesense exposes REST API also for searching. So you can send a query, and then you receive back a JSON response with all the hits, and then you can do whatever you want. Yes, exactly. So the instance search library is useful if you are building a web page with HTML components. If you are building someone else, when you just need the data, you can directly call the. In effect, I don't know if it's big enough, but when you perform some operation on the page, what the instance search library does is a REST API query to Typesense itself. So, for example, I cannot zoom this part of the page, but this call has been done to this Drupal 11, the dev site 8109, that is Typesense, is not Drupal. And you receive back a JSON object with all the information that you need. Okay. Yeah, yes. The library is not in the module itself because it's a different license. You have to probably you have to download it using some package manager or whatever. What you can do in your theme, because probably you have this in the theme of your project, is just provide the CSS to style all the widget to match your page. All the widget have specific CSS classes, so you can use to style them. The example page that we saw before in the search here, to implement this, if you look at the templates of this page in the module, just using CDN version of the library to point to instance search directly without, but it's not the correct way to, you have to use npm or, yeah. No, for the front end part, module does not provide anything. You have to implement it by yourself, but if you're using instance search, you can do nearly everything in 80 lines of code. So not yet. Okay. I have to go a little bit faster, probably. 10 minutes. Okay. So a couple of features that you can use in this for free, basically using Typesense and the module. For example, if I looking for single directory components, I don't receive any results. Even I know that there is a node in the contents that mention single directory components as a sentence. So I can create a synonym. So directly using Drupal interface, I can say, okay, when a Drupal search for SDC, for example, this is a synonym for, not plugin, but okay, I do some test. Okay, for, no, I forgot the locale, otherwise, because I'm searching in English. With this configuration, if I go back and search for SDC, it finds all the contents that also contains single directory components as a sentence. It is useful because probably your clients will be called something different from what you call, and they cannot find what they want. There is also a support for analytics built inside Typesense. So you can, for example, configure it to tell you how many queries does not return any results, and so you can use these analytics to understand if people are searching for something that can have a synonym, and you can provide a synonym to improve the experience. Okay. Another cool thing is that, for example, if I look for CK editor, for example, the first results is modules, probably because in the modules node, CK editor is mentioned a lot of times. And the second results is plugins, because maybe in that node, the term CK editor is mentioned not so much time as in modules. But, for example, I know that usually when my customer search for CK editor, they want the plugin page, because it's the page that contains all the information about CK editor, for example. Okay, the plugin page is the node 45. So I can configure Typesense to say when a people is looking for CK editor. Okay, the syntax is not so user-friendly, but we plan to implement a better interface to configure these kind of things. For example, when my user is looking for CK editor, I want that the node 45 in English, in this case, has to be returned as the first one in the result set. So I can add this. They call this feature or marketing or curation on the Typesense documentation. If I perform the same search again, the plugins is the first one. Okay. And for example, I don't want to return the modules page because it's misleading. It doesn't talk about CK editor. For example, the modules page is the 49. So I can edit this configuration and say that the node 49 in English is excluded from the research. And in this case, if I perform the same search, the plugin is the first one, module disappears from the results page. Okay. So all those features are provided by the Typesense module and the Typesense server, and Typesense module allows you to configure all of them directly in Drupal. So you can give all those pages to your site administration or editor or whatever that can configure all those things that are, this curation part is mostly useful when you have an e-commerce site, probably. So you want to promote a product when users search for something. No, No, there is an issue for that on the issue of Typesense, the server, because it can be useful to have this. This has been removed or promoted because there is a rule, but at the moment, no, it's not available. Okay, last thing, because time is running out. Of course, you can do AI, because AI is everything. So I have another index here that is the same on content of type basic page, but on the schema configuration, I have enabled the AI features. Okay. So we are using an LM. This configuration comes directly from the AI module, so you have to install the AI module and configure a provider. Right now we support only OpenAI, but we are working supporting the other provider. And you can say to the Typesense module to use this LLM on a specific set of fields to create the vector representation of the contents. So you can do semantic search if you know all this works. And usually you don't create the vector representation of all your node content, because it can be huge. In this case, there are a lot of text. Usually you split the text in smaller parts, because you need to retrieve the semantic meaning of your text. If you send 1,000 sentences, probably the semantic meaning is too wide. So you can specific the size of the chunk and the amount of token that overlaps from one chunk to the next one, to be sure that you not cut a sentence in the middle, for example. And then you can choose, for example, the set of fields that are added to each chunk, because usually the name of the node contains a lot of information. So you want the name of the node in each chunk. Okay. If you do this configuration and index, I don't launch the index right now because it takes a lot of time to build all the vectors. In this case, the node indexed is 49 as before, but the documents indexed on Typesense are 1,272 because my nodes are split in many chunks. Using this configuration, I can do semantic search and something like that, but one thing I can do is converse with my content with a technique that it's called RAG, that is Retrieval Augmented Generation. It is basically a term that is pervasive right now. So, for example, I can ask, let's try how to build a block. Let's say if this works. Okay. Do you, the one question I try is, do Drupal is able to AI? I don't remember if this one is one of the, okay. So in this case, the system returns with a sentence in human readable language. Yes, Drupal can integrate technology, etc., etc. And it lists all the nodes that you used to build these results. So basically, behind the scene, this sentence is transformed in a vector. Then Typesense does a cosine similarity to find all the documents that are semantically similar to the question. It sends all those information to OpenAI. In this case, OpenAI builds the response, and the response is returned to the customer. at this point, this is not integrated with the chatbot module that's provided by AI module in Drupal, but we are working on this. 1 minute more, just with the slides, then okay, so we are actively working on this module. There are some missing features, so if you want to contribute to it, feel free to join on Slack or the Drupal.org issue queue. One of big missing point, the 2 missing points are tests and documentation. We need more integration with the AI module because we want to use Typesense also with AI search. And then, as I said, analytics and so on are available on Typesense server, but it's not integrated in Drupal right now. So there is a lot of work to do. If you have time or if you can, feel free to help. Thank you.
Thank you very much. So we are out of time. So
okay, so we can.
You continue the conversation in the hallway, like it's always the best place to have this kind of conversation. Thank you very much.